that Engel book is the Bible of spectroscopy or spectrochemical method. So if Bard, who just passed away, is the Bible in electroanalytical chemistry, so Inglewood, okay, is the one that we could say is the one that is an authority with respect to spectrochemical analysis. So this James Ingle and Stanley Crouch. Okay, so all spectroscopy or spectrochemical method of analysis course usually use that book as, we could say, the source. Okay, the basic has just been the same. We could say you just updated some of the aspect that you have there in the what we call analysis. So if we're going to look at the spectrochemical method, we could say this is the most widely used of all analytical method, one of the major tools of analytical chemistry. Okay, so if you're going to look most of these analysis around us, if it involves matter-light interaction, we could say that is a spectrochemical analysis. So trace metal are most frequently carried out by what? AAS. Okay. So AAS, or the atomic absorption, okay, that will be one of the main topic that we have. And then you have the UV and visible absorption. Usually they are molecular absorption and fluorescence method. They are extensively employed for the determination of both metallic and non-metallic elements. So for inorganic or organic species. So if you're going to look at this, spectrochemical instrumentation is used not only for direct analysis, but also as a tool to monitor chemical reaction or the influence of this chromatography or automated flow analyzer. So even though if you use chromatography, so once you separate the components in chromatography, usually you use a spectrochemical method to determine those separated components. So if you're going to look at these words, so it's a compound word. It's made up of what? Spectro and chemical. So if you're going to look at spectro, it is, we could say, from the word spectrum. Okay, so a spectrochemical is just a compound word that comes from spectrum and chemical. So a spectrum, okay, that is what? What do you call this in English? Singular form. So ano yung plural form nito? Spectra. Okay, so when we're talking about a spectrum, it's a display on the intensity of radiation emitted, absorbed, scattered by a sample versus a quantity related to a photon energy such as wavelength or frequency. Okay, so if you have, let's say like this, you have here the wavelength, so it could be what? Maybe like this one, okay, and you have here what we call the absorbance, or you can have it either the emission intensity. Now, if it's what we call the frequency, so synonymous to that is the so-called wave number, okay, and you have here either what? The percent transmittance, if you have it like this, or if you have the absorbance, you can have it like a mirror image. So that is what we call a spectrum. Okay. So intensity of the radiation. So it could be radiation that was absorbed, emitted, or scattered by a sample versus the wavelength or frequency, quantity related to photon energy. Okay. And if we're going to look at this spectrochemical, so this is, we could say, a spectrum used to determine the chemical species and to investigate the interaction of chemical species with electromagnetic radiation. Okay, and when we're talking about spectrochemical methods, it involves in direct optical measurement of the photons, okay, related to photon energy such as wavelength and frequency. Okay, so those are, we could say, the terms, the general terms that we have, spectrochemical. Okay, and later on you will know how it is, we could say, different or at least related to this so-called spectroscopy. So meron din tayong term na tinatawag na spectroscopy as we go on. Yeah, I think that is the next slide. Okay, so usually we interchange these two terms. But if you're going to look at this, they're not really the same. Where do you hear this spectroscopy? So usually when you're talking about what? Absorbance, fluorescence, or luminescence, okay, as they call it, okay? Raman, IR, or what we call vibrational spectroscopy, okay? So when you're talking about spectroscopy, this is just, we could say, the science that deal with the interaction of electromagnetic radiation with matter. So when we're talking about spectroscopy, okay, it's a branch of science that studies the interaction between light, which in this case is electromagnetic radiation, versus matter. So yan yung kabuuan ng tinatawag nating spectroscopy. Okay? So the interaction of radiations and matter, these are the subject of spectroscopy. And we can call it what? Spectrochemical methods. Now, when does this term become spectrometry? Saan natin nagagamit ng spectrometry? Anyone? Anyone? Saan nyo nagagamit yung spectrometry? Instrumentation. But usually what do you... This one. Mass spec. What is the spec there in mass spec? Is it spectroscopy or spectrometry? Right? I remember in 137, I have a true or false question. I always put there, mass spec, MS means mass spectroscopy. Is that true or false? Maybe lumabas din yung question na yan sa quiz nyo. Is that statement true? MS means mass spectroscopy. Tama ba yun? Okay, so usually it's a false. Okay, spectroscopy, we could say that's the overall, as long as there's a matter-light interaction, that is spectroscopy. But if you look at the word spectrometry, it's more restrictive term, okay, than spectroscopy, and denotes what? The quantitative measurement of the intensity of the electromagnetic radiation at one or more wavelengths with photoelectric detector. So we could say it's just the measurement of the intensity of radiation with a photoelectric transducer or other types of electronic device. Okay? So yan yung difference ng dalawa. Okay? So if you're going to look at this term spectrometry, so we could say it is some way like a spectroscopy, but okay, does mass spec involve EMR? Involved ba ang electromagnetic radiation sa mass spectrometry? What can you say? In some courses, they include mass spec as a spectrochemical method. But for me, I usually doubt it because the one that I want to include in spectrochemical methods are just that has interaction with light. There's no interaction of light with respect to the mass spec. Okay. So although some book in the spectroscopy include this method, but these methods doesn't involve electromagnetic radiation. What else ang kasama sa spectroscopy? Pero wala naman ang electromagnetic radiation. I think this acoustic stuff. Okay. Now, if you're going to look at this radiation matter interaction, which is mostly the one that we'll be focusing on as the semesters go on, okay, we could say there are several types. So one that involves transitions between specific energy states of chemical species, the one we have absorption and emission. Okay, so this radiation matter interaction we could say EMR is the one that is involved. So if you have EMR, what is that? Electromagnetic radiation. I'm not sure if I have, okay, there's a drawing that I have there. But if you're going to look at this electromagnetic radiation, it's a form of energy that is transported through space at high velocity. And the electromagnetic radiation, we could say, has what? A double nature. Or in Gen Chem, what do we call that? A dual nature. Okay? It can be what? Ano yung dual nature ng light or electromagnetic radiation? Anyone? Those teaching Gen Chem?
Wave and particle po.
Okay, so it is a wave in one form and a particle in another form. So if you're going to look at the properties of this, we could say electromagnetic radiation, you can describe it as a wave with properties of what? Pag wave siya. Ano yung property na involved kapag wave? So you have what we call the wavelength, the frequency, okay? Alin pa? Velocity, and amplitude. Anything that you could see in a wave, right? So you all know in Gen Chem, wavelength is just the distance between two successive waves. So it could be the highest point, the lowest point, or any point as long as they are what we call the same point, consecutive points. Now, frequency is the number of waves in a given time. Okay? And then we have what we call velocity. So the wave phenomena that we have here, which include what? Refraction, reflection, interference, tsaka ano pa? This is involved, we could say physics and some Gen Chem. Diffraction. Now, electromagnetic waves, in contrast to acoustic waves, they require no supporting medium for transmission. It can propagate through vacuum. Right? Yan yung tinatawag natin difference ng acoustic waves doon sa electromagnetic waves. Electromagnetic waves can be what? In vacuum. Okay? Now, in addition to this, so we have the wave property. Ano naman yung mga particulate property? O yung particles. So it can be described in terms of photons. Ano pa other term? Quanta. Okay. So the other dual nature that you have there, this particle, you can describe electromagnetic radiation as consisting of photons or what we call quanta. It is necessary as the wave model fails to account for the absorption and emission processes. So for these processes, usually the electromagnetic radiation is best treated as a discrete packets of energy. And how do you treat this as what? As a particle? Papasok yan. Ito. Si Planck constant. So Planck described the energy of photon as what? H times B. When which if you expand this, what will happen to this? Ano yung other definition ng frequency dito?
C over lambda po.
Okay, C over lambda. So if you're going to look at this, so this is where you combine the two properties. Okay. So the energy of a photon can be related to its wavelength, frequency, or wave number. Okay. And out of this, you can have what? The so-called radiant power or the so-called intensity. P. That's in watts. So this is the energy of a beam that reaches a given unit, a given area per unit time. And the power of radiation is usually directly proportional to the number of photons per second. Okay, so that's one form of the radiation matter interaction. Now, the other form of what we call radiation matter interaction is the one that doesn't involve transitions between energy states, but rather causes changes in the optical properties of the radiation, like direction and polarization. And you have this: reflection, refraction, diffraction, and scattering. Okay? So this one is not common compared to this one. So this one, what do you have here that can use in spectroscopy? So usually you have here your UV-Vis, your IR, and your fluorescence or luminescence, because it can involve both the fluorescence and the what we call phosphorescence. Okay, so in this course, you will know the difference between fluorescence and phosphorescence. I don't know if you have the term before. Narinig niyo ba yung mga term na yun? Have you heard those terms before? Have you done any fluorescence study?
Narinig lang po pero wala pa pong
Because
wala pong instrument.
yeah, that's what I heard. That's why I'm trying to set aside some money here if I can buy a portable one. So kung ma-approve yung application this summer, I will try to bring that portable spectrophlorimeter. So the company gave me the quote. It's around what, 9,000? So I tried to come up money, okay, so that I can buy it before the end of the semester. Now, the second type of radiation matter interaction, we could say these interactions are often related to what? Bulk properties of the sample rather than to specific chemical species. So yung nauna, it based on the property of a particular substance. But here, you look at the bulk properties, and there are several analytical techniques that are based on these so-called bulk properties. Okay, and if you're going to look at the electromagnetic range for this spectrochemical analysis, it can go to what? As the gamma rays that has more than 10 to the 19 hertz, or the audio frequency, which is less than 20 kilohertz. But for the optical spectrochemical analysis, the focus that we have is what? The UVBs and the IR. And if you're going to look at these optical spectrochemical analysis, the requirements that you have is what? Very similar. The materials used for dispersing, focusing, and directing the radiation are conventional what? Optical glasses. So you have here the glass, the quartz, or the alkali halide crystal. So you know where the glass and the UV and the quartz are used, right? You use it in UVB. So where do you think this alkyl halide crystals use? Like NaCl and AgCl. Saan kaya nagagamit yan? Anyone?
IR po, sir.
IR. Okay. So usually you sandwich if you have a liquid on that one. And the thing is you have to be very careful because if you have a water-based solution, you don't want the NaCl to be used, or else what will happen if you use the NaCl with a water-based solution or sample? Most likely, ano nangyayari dun sa window mo?
Magbi-bleed lang po, sir.
Magdi-dissolve siya. Because usually what we do is we use a silver chloride. Okay. So after we do the analysis, we wipe it dry. Okay. And then let it dry. So if you're going to look at these optical spectrochemical techniques, you can divide them into two. One at the atomic level that has what? Pre-atomic species in the vapor state, and the molecular spectroscopy, wherein you have a molecular species in the solid, liquid, and in the IR state. So what do you think is the main difference between the two? Sige nga. Based on your knowledge, ano main difference ng dalawa? Practical difference. Which one is destructive and which one is non-destructive?
Spectroscopy po yung destructive.
Ha?
Spectroscopy po yung destructive.
Okay. So yung una yung destructive. If you're going to look at the light source that they have, maybe they have the same light source, but the other one, you have to put it in atomic species. You have to free it in atomic species, and the only way for you to do is to heat it. So heating it will destroy it. You cannot recover it. Unlike in the molecular species spectroscopy, you can recover them. The thing that my experience that I have, I can run 4 instruments, and all I need was 1 cubet. So what I do from 1 cubet, okay, I mean the 1 cubet from UVBs, emission spectroscopy, Raman spectroscopy, and sometimes CD. Okay, circular dichroism. I cannot use it in IR because kailangan kong ilagay doon sa sandwich. Okay? And sometimes it's hard to recover once you sandwich them. Okay, so that is what we call some of the spectrochemical analysis that we have. So if we're going to look to focus on the photon energies that we have, so this is the electromagnetic radiation. So the photon energies that we have, joules, ergs, electron volts. So for 1 erg, that's 10 to the -7 joules. 1 electron volt is 1.6 times 10 to the 19 joules. And if you're going to look at the wavelength of radiation, so the one that is commonly used is what? Nanometer, which is 10 to the -9 meter. You can go to the angstrom level, that's 10 to the -10 meter. And micrometer is what? 10 to the -6 meter. And 1 electron volt is equal to 1240 nanometer. Now, if you're going to look at the wave number, you can look at it in terms of what? 1 over the wavelength, or 1 over, okay, the speed of light over the frequency, or frequency over speed of light. And you can relate it as just what? The energy over the Planck constant times the speed of light. And in the electromagnetic spectrum, okay, so you have here the shortest wavelength and you have here the longer wavelength. And we have a small region where we can see the colors around us, the visible region. Okay, so you know what the Roy G. Biv means, right? So this is usually what? The longest one, and this is the shortest one. And in terms of what we call the frequency, the shortest one has the higher frequency, the longer one has a lower frequency. And in terms of energy, okay, the shorter wavelength has the higher energy, while the longer wavelength has a lower energy. That's why if you're asked blue versus yellow, which is hotter or warmer?
Blue.
Usually it's the blue, although we said what? Cool blue. But cool blue is really warmer than what we call yellow. And if you go further in this, what we call violet, if you go further there, anong tawag dyan? Ultraviolet. And one evidence that the ultraviolet is high energetic is what? Pag nagbilad ka sa araw, iyan yung makukuha mo. Tan. And sometimes your sunburn can be what? Painful. Have you experienced there? Na-experience yung bang masunog sa araw? I never experienced there in the Philippines, but some of the folks that I know here, whenever they have sunburn, you cannot touch their back because they said it's really what we call painful. Okay? Now, based on this electromagnetic radiation, you can have the different, we could say, spectroscopic methods. And we can look at this as what? From the highest energetic to the lowest. And based on the energy that they have, you can look at the so-called transfer or quantum transition that they have. So gamma ray emission is the shortest wavelength. Okay, so that means that's the most powerful or the highest energy. So the type of quantum transition there is within what? The nuclear. And maybe you're familiar with gamma rays with Incredible Hulk, but as you know, when you're exposed to it, you're not really become the Green Hulk. Okay, most likely you die. And then we have the X-ray absorption, emission, fluorescence, and diffraction. So we have the XRA, XRF, and XRE, D. And the one that usual wavelength that you have is between 0.1 to 100 angstrom. And what you have, there's inner electrons. So where do you think they use it? Where do you think you use the XRF and XRD? I have experience using both of them. The XRF is just a gun, but it's a very big attache case that we have there. Because I was thinking of bringing it in Marinduque to monitor. What do you think I want to monitor in Marinduque? Anong problem sa Marinduque? Anyone? The mining. So XRF is usually to detect metal. Okay. So in the lab, what we do, we demonstrate them. I ask my students to bring any metal, and the XRF will tell you the composition of the metal. Okay. And I think one of the research that comes out there is they were able to use XRF to determine adulteration in honey or bee products. So one researcher in PNRI was able to develop that. Now, XRD, on the other hand, you use it to determine particular solid sample, salts. So what it do, you put your solid there and it's going to match, okay, to the length of these salts, the interaction of the sodium, what we call cation and anion. Okay. Now, the next type of spectroscopy that you 10 to 180 nanometer, you have what? Vacuum ultraviolet absorption. So I have not experienced using that. So the usual wave number is 1 times 10 to the 6 to 5 times 10 to the 4. And the quantum transition type there is bonding electrons. So I think it's just typical UV-based, but you do it in vacuum. So the one that I have experienced is this one. That's why I don't know if you have a Google Scholar. So what I did this week, okay, try to see what the word cloud that come out from my Google Scholar. And what do you think came out in the Google Scholar? I'm trying to see if we can share it. So I'll try to share to you what came out in my what we call search for the word cloud. So this is the word cloud that came out. That's why I'm saying myself posted there on Facebook that of the 3 courses that offered there in UP Los Baños, I think I'm more qualified to teach this course, followed by what? Bakit my oyster? Because I have this so-called billion oyster project here in the US where I'm the chemistry person of that project. So it's $1 million project that our school got. So what it do is it trains students to at least put oyster back to the bodies of water around New York. Because what do oyster do? Marami bang oyster na lumabas? Kita mo yung oyster? Marami bang oyster? So if you're going to look yung chromatography, yun lang yung isa, oh. And then if you're going to look at the other one, voltammetric, that is what? Electrochemistry. Okay. And then I think there's an electrode here. But if you're going to look at the one that we have, mostly spectroscopy, spectroscopic, and I'm surprised, Raman. Okay? And then baka may makita pa kayo, bakit may amphetamines? So you try to play if you have a Google Scholar account, okay? And it will tell you what's the common words that come out of your presentations and we could say publications that you have. So I will really say, oh, now I'm at least more confident that I have the expertise to teach this course, much more compared to the electrochemistry. So here you have voltammetric. I think there's an amperometric before and then electrode. Okay. So when I look at this, so as isip ko talagang qualified akong i-teach itong course na to. And there's the electrode and I made the right decision that I'm not qualified to teach chromatography because you don't see anything here about chromatography. Okay. So just trying to share you the fun after you establish yourself kung ano talaga yung expertise mo. So UVBs is what we could say the experience that we have. I have access to both UVBs and fluorescence. That's why I'm trying to have this portable fluorescence. Okay. Na pwede kong dalhin dyan when I go. And then we have IR and Raman scattering. So these are both vibrational. So it's just what? Rotation and vibration. So I think, nag 140 ba kayo? Because I know AgChem has no 140. So siguro alam nyo na yung mga stretching, bonding. Like if you have water, my head is the oxygen and my two hands are what we call the hydrogen. So siguro alam nyo na yung symmetrical and asymmetrical. Meron ng 140 sa AgChem because during our time, we don't have it. And I know the Bible book there is Shriner, Ralph Shriner. Yung pa rin ba ginagamit? Si Shriner pa rin? Because I think I have a book that I got from the person who I replaced in the department. I think that was a book from 1981. So, although it is really in 140, I still learned it here. And I think among the spectroscopy, this is the one that I found easy. I have a portable Raman and I have access to a big Raman, which under repair right now, and a laser-based Raman. Okay, because you need a high energy source for the Raman. Okay. And then you have the microwave absorption, electrospin resonance. So one lab here in Brooklyn College, his specialty is an electron spin resonance. And then the NMR. The City College here has one building that houses different NMR. Ang laki ng mga NMR nila. There in the Philippines, sa Ateneo pa rin ba may NMR? Sa PIPAC? But I think LaSalle right now has a lot of instrumentation. How I wish UPLB will have its own set of instrument. Kaya? Ha? Nagpa-brown out pa ba? How is the power supply there? Kasi yan yung problema eh. Okay? Because we're hoping in the near future, we can have at least have a model just like LaSalle. And unfortunately, yung mga nagpapatakbo doon ay UPLB graduate. Okay? I think buying instrument is not the problem. It's maintaining the instrument that is the problem. You can always find fundings for the instrument. I heard meron kayong bagong IR, kaso umalis na yung in-charge nun, di ba? At hindi na alagaan. And some of you attended the voltammetric workshop. So it's just maintaining the instrument. Here, most of these instrument that you have, you can leave it open. There, kailangan mong i-protect kasi ang daming dust. Paano ba yun sa Tagalog? Hindi naman siguro pulbos. Ano bang tawag doon sa dust? And it can, we could say, ruin the optics. Alikabok. Maraming alikabok. Okay? So if you're going to look at this electromagnetic radiation, so we have the gamma rays, higher energy to the lower energy, or the shorter wavelength to the longer wavelength. And this is where the Roy G beam is. Okay. And if you're going to look at this at the applications that you have, so as I've told you, yung ultraviolet, the tan that you have there. So these are the applications that you have. So whatever the region, there is always an application that you have. Now, let's look at the types of what we call analysis. Okay? So parang review na rin to nung tinatawag nating Chem 32. Okay? So I have no choice. I just follow yung sa ano ni Engel and Crouch. So in the type of the, we could say spectrochemical analysis. So in spectrochemical methods, yung spectroscopy is used for the identification of chemical species, which is the qualitative one, and determination of the amount of a particular species, which is the quantitative one. Okay, so at first thought, you would say that the different goals of the qualitative and quantitative analysis would seem to dictate quite different approaches. However, ano ba usually yung ginagawa natin? We do qualitative first and then quantitative analysis, right? Tama ba? Are you going to do quantitative right away? Eh kung wala pala siya in the first place. You're just wasting your time. So the first thing that you're going to do is do a qualitative that answers the question, is it present? Okay. So if the answer to the question is yes, it is present, the next thing that you're going to do is how much is present. So at least we have a rudimentary knowledge of the quantity that is required. For example, mercury in the river water. Okay. So at first, we have to identify that the level of the mercury present in the river water exceed a certain threshold. So usually, ano tong threshold na to? A threshold that you consider that they are already what? Toxic, poisonous. Okay. So the qualitative analysis can be considered as merely as what? Low resolution type of quantitative analysis. So simply answering a binary question, yes or no, determination. Okay. Although quantitative methods is stressed out in every analysis, it is useful to keep in mind that similar consideration of uncertainty in the result, limits of detectability, upper concentration ranges, and error in the procedure also apply to qualitative methods. So someone mentioned about the oyster. So one aspect that we look is what? What does the oyster play in nature? Ano yung role ng oyster sa nature? So anyone? Sila yung tinatawag na ano? Bioaccumulator, or in layman's term, ano sila? Filter. Okay? Sila yung taga-filter ng mga toxic materials. So one aspect that we look is the presence of the metals. May AAS kami. But what do you think we got? We cannot say it's present. But, okay, to the point that our detection limit is set at the ppm level. So we say at ppm level, they're not present, but they can be present at ppb level. It's just happened that our detection limit cannot go lower than 1 ppm. So that's why in our results, we put ND. What is ND? Ano ibig sabihin ng ND dun? We're not able to detect. Okay, because of the limit in our what we call instrument. And the suggestion that we have is use not an AAS, but a more high-end one, I'm not sure if you're familiar with ICP. You're familiar with ICP? Okay, the ion coupled device that we have. Okay. And if we're going to look at this, what we call spectrochemical analysis, okay, we can look at it in terms of constituents determined in the spectrochemical method. In some cases, some spectrochemical methods are used to determine major constituents. So when you're talking about major constituents, it ranges from 1 to 100%. So maybe this is the one that you use when you do blood tests. So some of the company, they patent some of the reaction that they have. That's why by just mixing urine sample or blood sample with a reagent, they can produce something, a colored agent, and they already know the molar absorptivity. Now, if it's minor constituent, it is ranging from what? 0.01 to 1% relative weight range. And if it's race constituent, the species would be present in less than what? 0.01%. Now, if you're doing organic chemistry there, I know one professor, he wants to determine and characterize minor constituent of some endemic species and plant. Take, for instance, your sample is, are you familiar with amor seco? May amor seco pa ba dyan? Are you familiar with that? Yung pag naglakad ka, nakapantalon ka, may didikit sa yung manipis na manipis. Meron pa ba nun dyan? I know someone whose thesis was to determine the minor, I'm not sure kung anong functional group, diterpenes, galing doon. And imagine collecting one half sack, kalahating sako ng amor seco. Paano mo gaano kadaming amor seco yun? Okay? So that is, we could say, trace constituent. Maliit na nga yung sample mo, tapos mas maliit pa yung i-analyze mo. Okay? Now, you can also have this type of analysis in terms of what? The size of the sample. Okay? So yung una, constituent, major, minor, and trace. So the next one we could say is what? The size of the sample. So this is just back to 32, but the book has it. So you can classify it as either what? A macro analysis, where you have 0.1 gram, or more than 0.1 gram. A semi-micro analysis or meso analysis, where your sample is between 0.01 to 0.1 gram. Or a microanalysis where the sample size is in the range of 10 to the negative 4 to 10 to the negative 2. And if it's less than that, 10 to the negative 4 gram, you can have the ultra micro analysis. So sometimes they use the ultra trace, considered to be the determination of a trace constituent in an ultra micro sample. So ang liit na nga, talagang pinaliit pa. So those are, we could say, the term that you have. Okay? And then the samples. So, meron kang tinatawag na initial sample. So, the nomenclature for dealing with the samples used in spectrochemical analysis is often confusing and contradictory. But what we're going to use is we use the term initial sample to mean a portion or a subset of the bulk material about which analytical information is desired. Okay? So if we have this, what we call the example here, we have 1 liter of water obtained from the lake. So that is your initial sample. Okay? So the bulk material that you have there is the lake, right? And what you do, you want to determine the mercury content or a few grams of soil. That's your initial sample are acquired from a field, which is your bulk material, in order to determine the concentration of a pesticide. Now, in some cases, your initial sample is what? Treated in the form of grounding, heating, dissolution, dilution, pre-concentration, or separation. So that is your initial sample. Compare it to the other one, the analytical sample. So this is a portion of your initial sample presented to the instrument for spectrochemical analysis. Okay, now in some cases, as I mentioned, your initial sample is treated prior to the analysis. Now, in all cases, what is the condition that you need for your analytical sample? They should be what? They should be representative of the concentration of the sought for species. So they should be containing what? The amount or concentration of the analyte that you're looking for. Okay, in your what we call bulk material. So the sampling and the sample preparation steps are, we could say, the entire set of procedure done to acquire and to prepare the analytical sample from the bulk material. This is what? A critical step. Okay, and errors in sample preparation steps are carried through the entire and lead to errors in final results. So what does it mean? Kahit gaano ka-high-tech yung instrumentation mo, if your sample is not representative of the bulk materials that you're analyzing, your analysis is what? Useless. Okay? So sampling, unfortunately, play a very important role, and it can affect directly your results. Ini-emphasize ba nyo yan sa research nyo? It's easy if you have a lot of sample. All you need to do is what? Analyze it again and again. But what if your sample is limited? For the one that we have in the lab, we have a lot of samples. But there's a problem with our samples. Especially the stuff that I deal is what? Propolis, B products. What's the problem with the B products? Its constituent keep changing. To the point that I'm getting used to that the composition that I have of my brief propolis this year will be different a year after. Okay, so the only thing I can do is to minimize any changes that it happens. So how can I minimize that? I have to put it in freezer. So that's the hard part of this, what we call the analytical sample. And I think that's also an advantage because, you know, let's say in a material like the one that I have, B propolis, the one that I get from the Philippines is different from the one that I get here in New York City. Even the one that I get from the city is different from the one that I get from the suburb. And I always tell my students, you can never get wrong because there's no such thing as right amount or concentration of a particular compound. Why? What's the nature of, let's say, the sample that I use, the B products? They depend on what? they depend on the different factors. One of them is location. There's one article when the bee farmer got colored honey. And what do you think the reason why he got a colored honey? Anyone? What do you think the reason? Ano sa tingin niyo yung reason? I'm trying to get that thing because that puzzled me when I started to venture with what we called the bee propolis or the bee products, because before I really don't think that it should be. So I'm going to show you here the photo. So do you see this? Source for the nectar, flag pigments, pigment from the flower, colorful honey. Okay? And if you read the article, oh shit, ayaw akong bigyan ng ano, ng access sa article. If you read the article, the main reason for that, colored honey made by candy-eating French bees. So ano sa tingin niyo yung company near doon? M&M. Okay? So he ended up blue honey after visiting an M&M factory. So imagine yourself, you have a colorful honey because you're what we call bees visited the M&M factory. Okay? So the thing is that I want to emphasize, the strength of your analysis just depends on how your analytical sample is a representative for the material that you're analyzing. Usually a lot of people forget that. That's why no wonder the reading that you have, even if you get it from the same samples or from the same site, is very deep because they are not representative. Okay, or you didn't put extra care or effort in doing this analysis. So another term that we can have here, maybe this is already, we could say, familiar to you. So we have the so-called analyte. So analyte is the species to be determined in the analytical sample. So usually it is what? A compound or a pure substance, could be an element. And there may be several analytes in a given sample, and their concentration can vary what? From the trace level to the major constituent level. Now, anything that surrounds your analyte is what? The matrix. So it's the collection of all the constituent in the sample. So if I ask you which matrix is more complicated, pure water or environmental water? So alin mas complicated na matrix or complex na matrix? The pure water versus environmental water. So usually it's the environmental water because it contains other constituents there. Pure water, you could say it's just pure water. But an environmental water is water that contains whatever substances you found in the surrounding. And if you're going to be specific, you can look at the so-called analytical matrix. So it refers specifically to the matrix of the analytical sample due to the substance added or removed in sample treatment stages. So the matrix here, okay, if you treated it, that is already what we call an analytical matrix, because this is already now your analytical sample. Hindi na lang siya matrix because you already do some operation, some pretreatment to it. Okay? Now, if you have a matrix as defined here, and it includes the analyte as well the other constituent, you can also call it as what? Concomitants. So in a concomitants, this is, we could say, the dictionary meaning any phenomenon that actually accompanies or follows something. So the matrix here, as defined, includes the analyte as well as other constituents. Okay, are concomitants. So in trace analysis, the analyte is present in such small amounts that it is conveniently to speak of the analyte and the matrix separately. Okay, but in major constituent determination, the analyte is a major part of the matrix, and this division is no longer helpful. So example, in determining iron in steel, the analyte is usually what? The iron is always present in greater amount, okay, compared to the other metal. But if you're, let's say, trying to determine manganese in steel, so manganese present is less compared to the iron, which is the major metal in a given steel sample. Okay. So if you have the analyte that is iron present in large amount, as it determines to a large extent the bulk property, so we could say the matrix is no longer composed of just the concomitants. Okay, and in some analysis, information about specific chemical species is of interest. So we have here this chemical speciation. So this is determining concentration of specific chemical forms of the analyte. Let's say arsenic 3 from arsenic 5. The amount of the drug that is bound to the protein. Or what chromium is the one that is harmful, if you remember? Anong charge yung chromium that was featured in Erin Brockovich? Hexavalent chromium, right? I know there's a scene there. She's interviewing a teacher in chemistry, and she was asked, what type of chromium or which form of chromium? And she answered that why? There's different form. So that is what we call chemical speciation. Specific thing. So this is chromium +6. Now, how about the spectrochemical phenomena? So how do we do this, what we call analysis? So if you're going to look at this, these are just the possible spectrochemical phenomena that can happen. So this is stimulate the species, okay, by a variety of means. So first, the bombardment with electrons or other elementary particles, which generally leads to the emission of X radiation. So these are the one that has what? XRF, XRD, okay, XRA. So usually there's a bombardment of this electron. And then we have here exposure to electric current, an AC spark, or an intense heat source. It can be flame, DC arc, or furnace. So here you include the AAS, the UVBs, okay, and the infrared. So usually there's a light source that you have there. And then we have the irradiation with the beam of electromagnetic radiation, which produces fluorescence and radiation. So this is usually when you expose or apply an energy, what happened? The energy is absorbed and it will go to a higher energy level, and some of them, they go back. When they go back from the higher energy level to lower energy level, they will emit light in the form of fluorescence. We will going to discuss that. I'm not sure if you heard already this term. Have you heard this? Yung totoo. Have you heard this term? Jablonski diagram? Anyone? None? None of you heard this term before? I never heard it when I was there in UP Los Baños. Jablonski diagram describes everything that is related to spectroscopy. You will see some of them later on. And then we have an exothermic chemical reaction that produces chemiluminescence. So this is where I think the example is the firefly. It's an example of what we call the chemiluminescence. So you can have a bioluminescence or chemiluminescence or just luminescence, the overall stuff that you have there. Now, in most of these are involved this what we call following term, the ground state and the excited state, right? So you might say, oh, napaka-gen chem ito, but that's how this process is. If you have a portable UV beams, you can analyze. We have experiment that involves UV beams absorption in Gen Chem. Okay. So you're familiar with the ground state and the excited state, right? One is a stable compared to the other one. And if you're going to compare it in a real life, you can ask yourself, is excited state stable or unstable? Ano bang feeling mo kapag ano ka? I'm so excited. And I just can't fight it. Come on, come on, come on. So usually it's unstable because you are at a higher energy. And after sometimes you go back to what? Real life, right? So maybe last Wednesday, some of you or most of you are what? Excited state. Or others, you are what? Spending your single awareness day. Acronym what? SAD. So that's what happened also. Okay. So between the two, if you absorb energy, you go from ground state to excited state. Now, sometimes, since the excited state is unstable, it will go back to the ground state. Now, in some instance, for those molecules that emit radiation, okay, we could say it undergo fluorescence or phosphorescence. So any spectrochemical information that you have is provided by measuring the electromagnetic radiation emitted by the species as they return to the ground state from an excited state level, or by measuring the amount of electromagnetic radiation absorbed in the excitation process. So if you have absorption, there's a reduction in the intensity. Okay. And if you have emission, this is the process of which the photon is what we call being emitted. So we can look at this in terms of what? An absorption spectroscopy or a spectroscopy. So this is now what we call the part of the Jablonski diagram. By the end of the semester, you should at least learn what this Jablonski diagram is. So if you have not learned that before, so at least I will be happy if you're going to learn something that you don't know before. Okay? So wala talagang Jablonski diagram. Hindi nyo yan na-encounter. Yung totoo, class. You
Nakita
never
lang po, sir.
nakita nyo lang?
May
It was
pangalan
not discussed
pala.
to you?
Na-discuss po, sir, sa differentiation po nung fluorescence and phosphorescence.
Yeah, but the thing is, if you're going to look at this, yung Jablonski diagram, that's really how you differentiate one spectroscopic techniques from one another. So usually meron kayo mga line-line lang eh. Okay? But if we're going to look at this, meron siyang name. And to tell you, I'm not surprised because I only learned about this Jablonski diagram when I was already in what? Grad school here in the US. Okay? I have a course that is like 230 but split into 2 semesters. And I took a course that is what we call fluorescence spectroscopy. So that's where I learned more about this Jablonski diagram. Okay. So what do you think? What is Jablonski? It's named after a person whose name is Jablonski. So if ever you have a ski, usually what's the nationality kapag ski? Like Jaworski. Okay? It's Polish. Kapag may ski, usually it was we call Polish. So usually, yung si Jablonski na yan, the thing I learned it, right, what Carmel said, it is really used to picture fluorescence because Alexander Jablonski is the father of fluorescent spectroscopy. Okay? So dyan pumasok yung tinatawag na Jablonski diagram. So here, if we have the absorption spectroscopy, we measure the light, the amount of light that is what? Absorbed as a function of wavelength. And this can both give quality and quantitative method. Now, photoluminescence, on the other hand, okay, these are just forms of photoluminescence for analytical purposes. What? Your fluorescence and phosphorescence. So when we go on the part of luminescence, we're going to discuss it. But the difference between the two, so here you have what? From your ground state, light is absorbed. So your molecule goes to the excited state. Okay. Now in the emission from the excited state, since it's being unstable, so usually it goes back to the stable state, or what we call the ground state. So if you're going to look at the sample in terms of here, so you might have like any form of energy, and what the sample do is it can emit radiation. And based on the wavelength, you can determine how much of the energy is emitted, like this one. Now you can look at the photoluminescence and fluorescence. So ito na yung parang nagiging ano no, Jablonski diagram. So you have process that involves what? The photons. So ito na yung energy. So from here, from the ground state, it can go to the lowest excited state. So that's absorption. Okay. Now, if this goes back, okay, from the singlet state goes back, okay, to the what we call lowest state, that's fluorescence. Okay, but it has to pass through what we call some event here, the lowest that you have here. But if it passed through here from the singlet state going to the triplet state, that is phosphorescence. Okay? So yung difference nila, yung isa singlet, tapos yung isa triplet. I think that's, we could say, the simple difference between fluorescence and phosphorescence. Okay, but when we go to specific, when we go to the portion of what we call luminescence, okay, we will go into detail about the difference that you have. Okay, so the other way that you can look at it sa drawing, parang kapag nag-absorb ka, so yung isa, diretso doon, yun yung fluorescence, tapos yung isa, dadaan muna dito sa triplet state and then bababa. So that's the phosphorescence. Okay, and the red color that you have there, if you're going to look at this different energy level in the singlet state, that is vibrational relaxation. So if you go from the singlet state going to the triplet state, you have the intersystem crossing. Or if you go from the singlet state, excited singlet state to this ground electronic state, yun yung tinatawag nating internal conversion. But if it's just between the energy level in the electronic state, it's just vibrational relaxation. And it doesn't involve any radiation. Okay? Now, the chemiluminescence happen when the chemical reaction produce an electronically excited state which emits a photon in order to reach the ground state. So chemical reaction is usually involved. Yan yung tinatawag nating overall phenomena of photoluminescence. So question. I think I'll end here because this is the first type of that one type of energy or matter radiation interaction. Kasi yung next type is something to do with reflection, refraction, and other types. So I think that's another what we call time that I have. And kung matapos natin, I will upload the second slide for this. Now, question so far. May natutunan ba kayo? So pwede na ako mag-quiz this weekend? Chablonsky. With the history. So na-meet nyo na yung personality dun sa history? Na-meet nyo na sino? Sino yung responsible sa refraction of light? Sino yung father ng spectrometer? Are you familiar what I'm talking about? Yung tinatawag na photographic process. Sino yung nakadiscover ng tinatawag na IR light? At siya rin nakadiscover ng planet na tatawag ito Uranus or Uranus. So you know what? Kirchhoff and Bunsen. Okay. And how spectroscopy plus photography leads to the discovery of hydrogen in the sun's atmosphere. So usually I think that's the basis of the quiz, yung nasa recording natin. So you ready for that this Saturday para hindi matambak sa Quilgo at maka-libre ako sa Quilgo? So I'm just going to email everyone. Teka, andito na ba yung bago? Is Gis here? Wala. Because one of you left, but there's another one who's supposed to report already. Oh shit. Naka-record pala. Alam ko hindi naka-record. So question. Wala namang holiday next week, right?